What if the solar system you think you know is hiding astonishing secrets that could completely change your perspective on our place in the universe? From planets with mysterious rotations to hidden oceans teeming with possibilities, the cosmos is brimming with enigmas just waiting to be unraveled. In this video, we're diving into 25 mind-blowing facts about our solar system. Facts that even the most seasoned space enthusiasts might find surprising. Get ready to explore mysteries so profound they could reshape how you view not only the celestial bodies above, but perhaps even life itself. Buckle up, because the journey ahead will take you from the scorching surface of Venus to the icy depths of the Kuiper Belt and everywhere in between. You won't want to miss a single revelation, so let's lift off and uncover the astonishing truths that make our corner of the universe so utterly fascinating. Now turning to the very foundation of our celestial neighborhood, let's uncover the true age of the solar system. Scientists estimate that our solar system is an astonishing 4.6 billion years old. But how did they determine such an age with such precision? The secret lies within ancient meteorites. Using a technique known as radiometric dating, researchers analyze isotopes or variations of elements found in these space rocks. These isotopes decay at predictable rates, serving as cosmic clocks that allow scientists to measure how much time has passed since the meteorites, and by extension, the solar system itself first formed. This revelation is not just a number, it provides a window into the past, helping us piece together the story of planetary formation and the early conditions that gave rise to the worlds we see today. Understanding the solar system's age is crucial because it sets the stage for exploring how planets like Earth evolved to become capable of sustaining life. And that's just the beginning. Moving forward, let's illuminate the incredible engine at the heart of our solar system, the Sun. The Sun is not just a blazing ball of fire, it is, in fact, a giant fusion reactor. At its core, temperatures soar to around 15 million degrees Celsius, allowing hydrogen atoms to collide with such force that they fuse together to form helium. This process, known as nuclear fusion, releases an immense amount of energy in the form of light and heat, which travels across space and reaches Earth, making life as we know it possible. To put the scale of this energy into perspective, the Sun produces enough power every second to meet humanity's energy needs for hundreds of thousands of years. But here's a staggering truth: the Sun's fuel is not infinite. One day, billions of years from now, it will exhaust its hydrogen supply, marking the end of its life cycle as a stable star. When that happens, the Sun will expand into a red giant, engulfing nearby planets, including possibly Earth, before eventually collapsing into a white dwarf. This inevitable transformation reminds us of the impermanence of even the most colossal objects in our cosmos. The Sun's journey is a powerful testament to the dynamic and ever-changing nature of the universe. Now turning to the next captivating enigma, let's unravel the mystery of Planet 9. Beyond the orbit of Neptune, scientists have observed peculiar gravitational anomalies, hints that there might be an undiscovered planet lurking in the shadows of the outer solar system. This hypothetical world, often referred to as Planet 9, is believed to be a massive celestial body, roughly 5 to 10 times the size of Earth, orbiting the Sun at an extraordinary distance. But here's where it gets even more fascinating. This planet, if it exists, would take about 10,000 to 20,000 Earth years to complete a single orbit around the Sun due to its immense distance. So, why haven't we spotted it yet? That's the challenge. Its vast distance makes it incredibly dim, nearly invisible against the backdrop of space. Scientists rely on indirect methods to search for Planet 9, such as observing the unusual orbits of smaller objects in the Kuiper Belt, the region beyond Neptune filled with icy debris. These objects appear to be tugged by an unseen gravitational force, and that force could very well be Planet 9. Finding this mysterious planet would not only confirm its existence, but also revolutionize our understanding of the solar system's architecture. Until then, the hunt continues, captivating astronomers and space enthusiasts alike with the promise of uncovering one of the most thrilling secrets of our cosmic neighborhood. Moving forward, let's tackle a common misconception fueled by countless sci-fi movies: the asteroid belt. Picture scenes of spacecraft dodging massive rocks left and right, narrowly escaping catastrophic collisions. Exciting, right? But here's the reality. Our solar system's asteroid belt, which lies between Mars and Jupiter, is far from the densely packed chaos you see on the big screen. In fact, it's mostly empty space. While there are millions of asteroids within this region, the distance between them is astonishingly vast, often spanning hundreds of thousands of miles. This means that, contrary to what Hollywood suggests, navigating through the asteroid belt is relatively uneventful. Spacecraft like NASA's Dawn mission and others have passed through it with ease, with virtually no risk of collision. This sparse distribution actually helps scientists study individual asteroids more effectively, allowing them to gather insights about the early solar system. So, while the asteroid belt may not deliver the nail-biting drama of science fiction, its sheer scale and the secrets it holds about our cosmic origins are nothing short of awe-inspiring. Now turning to one of the most peculiar planets in our solar system, let's talk about Venus and its completely unexpected behavior. Unlike most planets that spin in the same direction as they orbit the Sun, Venus does the opposite: it spins backward. This means that if you are standing on Venus, the Sun would rise in the west and set in the east, a phenomenon astronomers call retrograde rotation. Scientists believe this bizarre rotation wasn't always the case. One leading theory suggests that Venus once spun like the rest of the planets, but was likely struck by a massive celestial body early in its history, causing its axis to flip over time. Another hypothesis is that gravitational interactions with the Sun and other planets may have gradually slowed Venus's rotation and eventually reversed it. What makes this even stranger is the length of a day on Venus. One single day on Venus, the time it takes to complete one full spin, is longer than its entire year, the time it takes to orbit the Sun. Specifically, it takes about 243 Earth days for Venus to complete one rotation and just 225 Earth days to orbit the Sun. This unusual day-night cycle leads to extreme environmental conditions, with temperatures soaring to levels that could melt lead. Such oddities make Venus an enigma and a challenge for planetary scientists who are eager to uncover its secrets. Moving forward, let's set our sights on the red planet Mars, a world that holds the title for hosting the largest volcano in the entire solar system. Meet Olympus Mons, a colossal shield volcano that stands at an astonishing height of over 13 miles, making it approximately 3 times taller than Mount Everest, Earth's highest peak. Stretching across a surface area similar to the size of the state of Arizona, Olympus Mons is not just a towering landmark but a testament to the incredible geological processes that once shaped the Martian surface. Its size and shape suggest it formed over millions of years through repeated lava flows that stacked layer upon layer. What's fascinating is that the lack of plate tectonics on Mars, unlike Earth, allows volcanic activity to occur at the same hotspot for prolonged periods, enabling structures like Olympus Mons to grow to such immense proportions. Scientists believe that Olympus Mons was likely active billions of years ago when Mars had a much thicker atmosphere and possibly even liquid water on its surface. Studying this massive volcano gives us a glimpse into Mars's ancient volcanic activity and its transition from a wetter, potentially habitable environment to the cold, arid planet we see today. As we continue to explore Mars, features like Olympus Mons remain key to unlocking the mysteries of its past. Moving forward, let's shift our attention to the solar system's giant, Jupiter, often nicknamed a failed star. This intriguing title stems from the fact that Jupiter shares some key characteristics with stars, primarily its composition of hydrogen and helium. However, unlike stars, Jupiter lacked the necessary mass to trigger nuclear fusion, the process that powers a star by fusing hydrogen atoms into helium under immense pressure and heat. For Jupiter to have become a star, it would have needed to be at least 80 times its current mass. Despite this, Jupiter's immense size and gravitational pull make it a vital player in our solar system. Acting as a colossal guardian, Jupiter's gravity influences the paths of numerous asteroids and comets, often diverting potential threats that might otherwise collide with Earth. In fact, Jupiter's gravitational field has been referred to as a cosmic vacuum cleaner, as it sweeps up space debris and minimizes the frequency of catastrophic impacts on our planet. Without Jupiter's protective presence, Earth might face a far more perilous existence. So, while it may not shine like a star, Jupiter's role in maintaining the delicate balance of our solar system proves that it's a star in its own right when it comes to cosmic importance. Now, let's journey even farther out to uncover the surprising youth of Saturn's iconic rings. Now turning to Saturn, the planet famously adorned with breathtaking rings, recent discoveries have revealed a startling truth about these celestial halos. While Saturn itself is over 4 billion years old, its rings appear to be astonishingly young, possibly forming just 100 million years ago. To put that into perspective, these rings might not have even existed during the age of dinosaurs on Earth. Scientists came to this conclusion by studying the composition and brightness of the rings. Unlike ancient structures, Saturn's rings are relatively clean and reflective, indicating their youth compared to the planet they orbit. But how did they form? One popular theory suggests that a moon or a comet ventured too close to Saturn and was torn apart by its powerful gravity, creating the billions of ice and rock particles that now circle the planet like a cosmic masterpiece. This discovery not only reshapes our understanding of Saturn's history, but also provides valuable insights into the life cycle of planetary ring systems. It raises questions about the rings' future too. Will they persist for billions of years or gradually fade away as particles drift into Saturn's atmosphere? The fleeting nature of such spectacular phenomena reminds us of the ever-changing dynamics of our solar system, leaving us to wonder what more there is to uncover. With lingering curiosity, let's now shift focus to another mysterious planet, Uranus, and its peculiar sideways spin. Moving forward, Uranus presents a unique and intriguing peculiarity among the planets in our solar system: its unusual sideways spin. Unlike most planets that rotate upright or with a slight tilt, Uranus takes this to the extreme with an axial tilt of 98 degrees. Imagine this icy giant rolling around the Sun like a ball on its side, creating seasons that last for 21 Earth years each. But how did Uranus end up in this peculiar position? One widely accepted theory suggests that a cataclysmic event occurred billions of years ago, where a massive celestial object, perhaps an early protoplanet, collided with Uranus, knocking it onto its side. This colossal impact would have altered not only its tilt but also its internal structure and possibly even the arrangement of its moons. The effects of this tilt are fascinating. As Uranus orbits the Sun, one pole is bathed in continuous sunlight for 21 Earth years, while the other remains in darkness for the same duration. This creates extreme seasonal contrasts that are unlike any other planet in the solar system. Additionally, the sideways spin affects its atmosphere, resulting in turbulent weather patterns and high-speed winds reaching hundreds of miles per hour. Despite its distance from the Sun and frigid temperatures, Uranus continues to fascinate scientists as they seek to understand the dynamics of its spin and the mysteries it holds beneath its hazy blue-green clouds. And speaking of extremes, let us now venture even farther out to Neptune, a planet where winds reach unimaginable speeds, rivaling even the most intense storms on Earth. With the next phase of the journey in sight, let us explore Neptune, the furthest planet in our solar system and home to a truly astonishing phenomenon, supersonic winds. On this strikingly blue planet, winds can reach mind-boggling speeds of up to 1,500 miles per hour, making them the fastest ever recorded in the solar system. To put that into perspective, these winds are more than twice the speed of a Category 5 hurricane on Earth, which is the most severe level of storm we experience. But what drives such extreme weather on this distant ice giant? Scientists believe that Neptune's immense distance from the Sun plays a significant role. With so little sunlight reaching the planet, temperatures plunge to an unimaginably cold -371 degrees Fahrenheit. This frigid environment creates highly condensed atmospheric conditions, which, combined with Neptune's rapid rotation, generate powerful jet streams. In addition, Neptune's composition of hydrogen, helium, and methane fuels its dynamic weather systems. Methane, in particular, absorbs red light and scatters blue, giving Neptune its vivid azure hue while also contributing to its turbulent atmosphere. Unlike Earth, where the Sun's heat powers the weather, Neptune's internal heat source, thought to be leftover energy from its formation, drives its chaotic winds. This internal warmth defies expectations for a planet so far from the Sun, adding yet another layer of mystery. Comparing these supersonic winds to Earth's, our strongest hurricanes and typhoons seem gentle by comparison. The extreme speeds on Neptune make it a world of unparalleled meteorological ferocity, captivating scientists who aim to uncover the secrets of its stormy atmosphere. And as we marvel at these alien weather patterns, let us now turn our attention to a much smaller, icy world, Pluto, where a heart-shaped glacier reveals surprising geological activity. Now turning to Pluto, a dwarf planet that holds a special place in our solar system, we find one of its most striking features, a heart-shaped glacier known as Tombaugh Regio. This iconic, bright region, named in honor of Clyde Tombaugh, the astronomer who discovered Pluto, is not just a charming visual but also a window into Pluto's surprising geological activity. Composed primarily of nitrogen ice, this glacier is far from static. In fact, scientists have observed that Tombaugh Regio exhibits signs of convection, where nitrogen ice slowly rises and sinks due to the faint warmth emanating from Pluto's interior. Remarkably, this process creates a constantly renewing surface, erasing craters and giving the region an unexpectedly youthful appearance. What's even more fascinating is that this movement happens on a world where temperatures dip to a bone-chilling -387 degrees Fahrenheit. Such activity suggests that Pluto, despite its small size and icy conditions, is more dynamic than anyone had previously imagined. The smooth, unblemished texture of Tombaugh Regio stands in stark contrast to other areas of the dwarf planet, which are pockmarked with ancient craters, revealing a landscape that is both ancient and newly sculpted. This heart-shaped glacier also hints at the presence of subsurface processes, possibly involving a hidden ocean beneath Pluto's icy crust. While the idea of liquid water on such a frigid world might seem implausible, it opens up tantalizing questions about the potential for life in the most unexpected corners of the solar system. Tombaugh Regio is a testament to how even the most distant and diminutive worlds can surprise us with their complexity. And as we leave the icy plains of Pluto, the journey takes us even farther out to the very edge of the solar system, where mysteries like the Kuiper Belt and the Oort cloud await. With the next phase of the journey in sight, we venture to the farthest reaches of the solar system, the Kuiper Belt and the Oort cloud. These two regions, shrouded in mystery, represent the outermost boundaries of our cosmic neighborhood. The Kuiper Belt is a vast, donut-shaped region of icy bodies located just beyond Neptune's orbit. It is home to countless small, frozen worlds, including Pluto, and is believed to be the birthplace of many short-period comets, those that complete their orbits around the Sun in less than 200 years. However, as distant as the Kuiper belt may seem, the Oort cloud lies even farther, forming a gigantic spherical shell that envelops the entire solar system. This hypothetical region, thought to be the source of long-period comets that can take thousands or even millions of years to complete an orbit, remains unobserved directly. Studying these far-flung areas poses immense challenges. The vast distances involved make direct exploration nearly impossible with current technology, and even the most powerful telescopes struggle to detect the dim, icy objects lurking in the darkness. Yet the Kuiper belt and the Oort cloud hold the keys to understanding the early solar system. These primordial remnants are thought to consist of material left over from the Sun's formation, offering a frozen snapshot of what the solar system was like over 4.5 billion years ago. By studying these regions, scientists hope to uncover clues about the processes that shaped our planetary system and the origins of comets, which may have brought water, and possibly even the building blocks of life, to Earth. As we ponder these distant, enigmatic frontiers, we are reminded of just how much remains to be discovered. And now, as we continue our exploration, we shift focus from the mysteries of the solar system's edge to the small but dynamic planet Mercury, where surprising geological processes are at work. Now turning to the small but extraordinary planet Mercury, we uncover an astonishing geological phenomenon. It is slowly shrinking. As Mercury's core continues to cool over billions of years, the planet itself is contracting, much like a grape slowly drying into a raisin. This process has caused Mercury's surface to wrinkle and buckle, forming enormous cliffs known as scarps. Some of these scarps soar miles high and stretch for hundreds of miles across the planet's surface. The discovery of these features has provided scientists with crucial insights into planetary geology, revealing how a cooling core can reshape an entire world. Mercury's shrinking also offers a rare glimpse into its internal structure, highlighting the dynamic processes that continue to shape rocky planets long after their formation. This ongoing contraction reminds us that even the smallest planets in the solar system can hold monumental secrets. And with this fascinating insight into Mercury's metamorphosis, we now look up to the cosmic dance between Earth and its closest celestial companion, the Moon, to uncover a surprising detail about their delicate relationship. Moving forward to the mesmerizing bond between Earth and its loyal celestial companion, the Moon, we uncover a startling revelation. Our Moon is gradually drifting away. Every year, it moves approximately 1.5 inches farther from Earth. While this may seem negligible in the short term, over millions of years, this slow separation could profoundly shape the dynamics of our planet. As the Moon recedes, its gravitational influence on Earth diminishes. This means our tides, which are powered by the Moon's pull, will slowly weaken, altering marine ecosystems and coastal landscapes over vast timescales. Furthermore, the Earth's rotation is intricately linked to the Moon's gravitational tug, so as the Moon drifts away, our days will lengthen. This is because the loss of the Moon's braking effect on Earth's spin causes the planet's rotation to gradually slow down. Remarkably, this cosmic dance between the Earth and Moon also offers scientists a precious timeline, helping them understand the evolution of our planet's past and its celestial mechanics. This gentle but persistent parting of ways between Earth and its companion is a humbling reminder of the ever-changing nature of the universe, even in phenomena that seem so stable to us today. Now, as we gaze beyond this dynamic relationship, we turn our attention to the fiery mysteries of the Sun, uncovering a puzzling secret about its outermost layer that has baffled scientists for decades. Now turning to the fiery enigma of our solar system's centerpiece, the Sun, we encounter a paradox that has puzzled scientists for decades. Its outer atmosphere, known as the corona, is mysteriously hotter than its visible surface. To put this into perspective, the Sun's surface temperature hovers around 10,000 degrees Fahrenheit, but the corona blazes at a staggering several million degrees. This defies conventional logic, as one would expect the outer layers to be cooler the farther they are from the Sun's core, where energy is produced. Scientists have proposed several theories to unravel this cosmic mystery. One of the most compelling is the idea of magnetic reconnection. This phenomenon occurs when the Sun's powerful magnetic fields twist and snap, generating bursts of energy that could heat the corona to these extreme temperatures. Another hypothesis involves waves of energy called Alfvén waves that travel from the Sun's surface to its corona, carrying immense amounts of energy. However, detecting and measuring these waves in such a volatile environment is no easy feat, and the exact mechanism of how they transfer energy remains elusive. Understanding the corona's behavior is not just a theoretical exercise, it has practical implications for us here on Earth. The Sun's corona is the source of solar wind, a stream of charged particles that can disrupt satellite communications, power grids, and even navigation systems during intense solar activity. Despite decades of research, the Sun's corona continues to challenge our understanding of solar dynamics, reminding us of how much there is yet to learn about even our closest star. With the Sun's blazing mystery in mind, let us now journey to Venus, a planet wrapped in extremes, as we uncover a shocking secret about its unique rotation. As the next challenge unfolds, let us delve into the extraordinary rotation of Venus, a planet where a single day lasts longer than its entire year. To put this into perspective, Venus takes 243 Earth days to complete just one full rotation on its axis, while it orbits the Sun in a swift 225 Earth days. This extreme phenomenon is a result of Venus's incredibly slow and retrograde rotation, meaning it spins in the opposite direction to most planets in the solar system. The implications of this peculiar rotation are profound. For one, Venus experiences prolonged periods of daylight and darkness, leading to extreme surface temperatures that can soar to nearly 900 degrees Fahrenheit during the long, sunlit stretches. This poses immense challenges for any exploration mission, as spacecraft must endure these punishing conditions. Furthermore, Venus's thick atmosphere, composed primarily of carbon dioxide with clouds of sulfuric acid, traps heat in a runaway greenhouse effect, making its climate one of the harshest in the solar system. These conditions not only test the limits of modern technology, but also provide scientists with a unique opportunity to study climate dynamics that could inform our understanding of similar processes on Earth. Despite its challenges, missions like the Magellan spacecraft and the proposed Da Vinci mission aim to unlock Venus's mysteries, revealing more about its history and the reasons behind its unusual rotation. With this fascinating insight into Venus's prolonged days, let us now turn our attention to Jupiter, a colossal planet that guards the solar system with its immense gravitational pull. As the next phase of our cosmic journey begins, let us focus on Jupiter's Great Red Spot, a massive storm that has raged on the planet for centuries. This colossal swirling storm, larger than Earth itself, has been one of the most iconic features of our solar system. However, recent observations reveal that the Great Red Spot is gradually shrinking, a change that has left scientists intrigued and puzzled. In the late 1800s, the storm was estimated to measure over 25,000 miles across, but today it spans less than 10,000 miles. This remarkable transformation raises questions about Jupiter's atmospheric dynamics and the forces driving this change. The Great Red Spot is sustained by Jupiter's powerful jet streams, with wind speeds reaching up to 400 miles per hour. These winds, coupled with the planet's lack of a solid surface, create a chaotic and ever-shifting atmosphere. Yet, the gradual reduction in size suggests that the energy fueling the storm may be fading over time. Some researchers speculate that this could be part of a natural cycle, while others propose that interactions with nearby atmospheric features may be playing a role. The shrinking of the Great Red Spot also offers an opportunity to study the complex interplay of factors that shape Jupiter's weather patterns. providing insights into the mechanics of gas giant atmospheres. Despite its diminishing size, the storm remains an awe-inspiring phenomenon, a testament to the dynamic and ever-changing nature of our solar system. With this glimpse into Jupiter's mysterious atmosphere, let us now shift our focus to Saturn, where its breathtaking rings hold secrets that are as fascinating as they are fleeting. Now turning to Saturn, the planet famed for its stunning rings, recent discoveries reveal a surprising truth. These majestic rings are gradually disappearing. This phenomenon, often referred to as ring rain, occurs as particles from the rings are pulled in by Saturn's gravity and descend into its upper atmosphere. These particles, composed primarily of icy fragments with traces of rock and dust, vaporize as they make their fiery descent, creating a delicate glow that surrounds the planet. Scientists estimate that this process drains a substantial amount of ring material over time. Current studies suggest that the rings might vanish completely within the next 100 million years, a blink of an eye in cosmic terms, given Saturn's age of over 4 billion years. This revelation raises profound questions about the transient nature of ringed planets and the forces at work in their formation and evolution. The loss of Saturn's rings also offers a unique opportunity to study their composition and structure, as well as the interactions between the planet's magnetic field and its surroundings. Perhaps most intriguingly, this process reminds us that the features we often consider permanent are, in reality, fleeting on a cosmic scale. With each passing moment, Saturn's rings continue their transformation, leaving us to wonder what the planet might look like millions of years from now. As we reflect on this mesmerizing yet impermanent spectacle, let us journey onward to explore Europa, a moon of Jupiter that harbors secrets beneath its icy surface unlike any other world in our solar system. With the next phase of the journey in sight, we arrive at Europa, one of Jupiter's most fascinating moons. Beneath its thick shell of ice, Europa is believed to conceal a vast, salty ocean, an ocean that may hold more water than all of Earth's seas combined. This hidden world has captivated scientists for decades, not just for its sheer size, but because it offers one of the most promising environments for potential life beyond our planet. The evidence for this subsurface ocean comes from multiple sources, including data from spacecraft like Galileo, which detected magnetic signatures suggesting a conductor beneath the surface, likely a global ocean of salt water. Furthermore, images reveal cracks and ridges on Europa's icy crust, hinting at a dynamic world where water from below might occasionally erupt onto the surface, bringing with it the intriguing possibility of organic compounds. This tantalizing notion has led to ambitious plans for exploration. NASA's upcoming Europa Clipper mission aims to investigate this icy moon in unprecedented detail. Scheduled to launch within the next few years, the spacecraft will carry advanced instruments designed to study Europa's surface and detect signs of habitability. Through a series of flybys, it will analyze the moon's ice shell, measure its magnetic fields, and search for plumes of water vapor escaping into space. These plumes, if sampled, could provide direct evidence of the ocean's composition and perhaps even indications of life. Europa represents a frontier in the search for extraterrestrial life, reminding us of how much remains to be discovered in our cosmic neighborhood. As scientists prepare to unlock the secrets of this icy enigma, the possibilities seem as endless as the ocean it conceals. Moving forward, let us venture even further, exploring the history of water on Mars and what it reveals about the red planet's past. Now turning to Mars, the red planet holds a story etched in its surface, one of rivers, lakes, and oceans that once flowed billions of years ago. Evidence from rovers and orbiters paints a vivid picture of a planet that was once much warmer and wetter. Features like vast dried riverbeds, ancient lake basins, and delta formations indicate that liquid water carved its mark into Mars's landscape. Minerals that form in the presence of water, such as clay and sulfates, have been discovered in abundance, further supporting the idea of a watery past. These findings suggest that Mars not only had water but may have hosted the conditions necessary for life. The discovery of these features has transformed Mars into a key focus in the search for extraterrestrial life. It raises the tantalizing question, could microscopic life have once thrived in these ancient Martian waters? To probe this mystery, scientists have designed missions equipped with advanced technologies like the Perseverance rover, which is currently exploring Jezero crater. This site was chosen because it is believed to have been a lake billions of years ago, with a river delta that could have transported organic material into the basin. Perseverance is collecting rock and soil samples to search for signs of ancient life, with plans to return these to Earth for detailed analysis. These efforts underscore the incredible potential Mars holds as a time capsule of habitability in the solar system's early history. As we continue to unravel Mars's watery past, it offers a deeper understanding of how planets evolve and what conditions might allow life to emerge. With these insights, we now look beyond Mars and into the fate of our own Sun, exploring its fascinating journey and eventual transformation in the distant future. With the next phase of the journey in sight, let's turn our gaze to the very heart of our solar system, the Sun, and uncover its ultimate destiny. Despite its brilliance and immense energy, the Sun has a finite lifespan. Unlike the dramatic supernova explosions often associated with massive stars, our Sun's future promises a different, though equally fascinating, transformation. Billions of years from now, as the Sun exhausts its hydrogen fuel, it will swell into a red giant, expanding to engulf the inner planets, potentially including Earth. This phase will mark a dramatic shift, with its outer layers expanding and cooling, turning the once yellow star into a colossal reddish celestial body. However, this expansion is not the end. After shedding its outer layers into space, creating what is known as a planetary nebula, the Sun's core will remain and collapse into an incredibly dense object called a white dwarf. This white dwarf, about the size of Earth but with nearly half the Sun's original mass, will slowly cool and dim over time, eventually becoming a faint, cold remnant. This process is a natural part of the stellar life cycle for stars like our Sun. The implications for the solar system's future are profound. As the Sun becomes a red giant, the intense heat and radiation will render the inner planets uninhabitable, while the outer planets and their moons may experience a temporary warming. The ejected outer layers of the Sun could enrich the surrounding space with elements that might contribute to the formation of new stars and planets. This transformation serves as a stark reminder of the dynamic and ever-changing nature of the universe. By studying similar stars at various stages of their life cycles, scientists can better understand how our Sun's evolution will unfold and how it influences the cosmic environment. Now, as we marvel at the Sun's long-term journey, we shift our focus to the early clues of the solar system's past, exploring the intriguing role of Trojan asteroids. Now turning to the fascinating role of Trojan asteroids, these celestial companions share their orbits with larger planets, most notably Jupiter and Neptune. Positioned in stable regions known as Lagrange points, these asteroids lead or follow their host planets on their orbital paths around the Sun. But what makes them so intriguing is not just their unique location, it is their historical value. Scientists believe these asteroids are ancient remnants from the early days of the solar system, essentially frozen time capsules that offer vital clues about its formation and evolution. For instance, by studying the composition and distribution of these asteroids, researchers can gain insights into the primordial materials that coalesced to form the planets. The Trojan asteroids around Jupiter, for example, are thought to hold traces of the same elements and compounds that were present during the birth of the solar system over 4.5 billion years ago. Similarly, Neptune's Trojans may reveal valuable information about the outer regions of the solar system and how the giant planets migrated to their current positions. What is even more remarkable is that their stable orbits have preserved them largely unchanged for billions of years, making them a goldmine for understanding the conditions in the protoplanetary disk, the vast, rotating cloud of gas and dust that gave rise to the planets. Missions like NASA's upcoming Lucy spacecraft, designed to explore Jupiter's Trojan asteroids, aim to shed light on these ancient objects, potentially rewriting what we know about the building blocks of planets and the processes that shaped our cosmic neighborhood. As we delve deeper into these relics of the past, we uncover yet another layer of the solar system's story. Now, let us venture even farther into the frozen outskirts of our solar system to explore the mysteries of comets and understand why they are often called frozen time capsules. Now turning to the fascinating nature of comets, these icy wanderers of the solar system are often referred to as frozen time capsules, and for good reason. Comets are composed of a mixture of ice, dust, and rocky material, remnants from the very formation of the solar system over 4.5 billion years ago. Preserved in the frigid outer regions of the solar system, they have remained largely unchanged, making them invaluable to scientists seeking to uncover the secrets of the past. Their cores, known as nuclei, carry pristine samples of the primordial materials that were present in the protoplanetary disk, the rotating cloud of gas and dust that gave rise to the Sun and planets. When a comet's elliptical orbit brings it closer to the Sun, the increased heat causes its icy components to vaporize, creating the spectacular glowing coma and tail we see from Earth. But beyond their striking beauty, these phenomena offer researchers the chance to study the composition of the comet's materials, providing direct evidence of the solar system's initial building blocks. For example, analyzing the gases, organic compounds, and trace elements released from a comet can reveal crucial details about the environment in which the planets formed. Missions like the European Space Agency's Rosetta, which studied Comet 67P, have already supplied groundbreaking insights into these icy bodies, suggesting that comets may have even delivered water and organic molecules, the essential ingredients for life, to Earth in its early stages. In this sense, comets are not only messengers from the past, but may also hold answers to one of humanity's greatest questions: where did life originate? As we continue to study these ancient travelers, each discovery deepens our understanding of the solar system's origins while unraveling the intricate tale of how our cosmic neighborhood came to be. Speaking of the outer reaches of the solar system, let us now explore the elusive and mysterious Sedna, a distant dwarf planet with an orbit unlike any other. Now turning to Sedna, this distant dwarf planet stands out as one of the most intriguing mysteries of our solar system due to its highly unusual orbit. Unlike the nearly circular paths of most planets, Sedna follows an elongated trajectory that takes it to the farthest reaches of the solar system, and then back again in a journey lasting approximately 11,400 Earth years. At its closest point to the Sun, Sedna is still more than 80 times farther away than Earth, and at its most distant, it ventures nearly 900 times this distance. Such an extreme orbit raises fascinating questions about what lies beyond the familiar planets. One of the most compelling hypotheses is that Sedna's path might have been influenced by the gravitational pull of an unknown massive object, possibly the much-debated Planet 9. Alternatively, Sedna's orbit could be the result of interactions with other stars during the Sun's early years in a dense stellar nursery. This remote object represents a tantalizing clue, suggesting that there's much more to the solar system than meets the eye. Studying Sedna provides astronomers with a rare window into the outermost regions, where the solar system ends and interstellar space begins. Its discovery has spurred new efforts to map the distant outskirts of our cosmic neighborhood and to better understand the forces that shaped its formation. Could other objects like Sedna be out there, hidden in the vastness of space, waiting to alter our understanding of the solar system's boundaries? As we ponder this, let us now look deeper into the journey of energy within the Sun itself, a process so intricate that the energy it generates takes thousands of years to reach its surface. Moving forward, let us dive into the fascinating journey of energy within the Sun, a process that defies the imagination in both complexity and timescale. Deep within the Sun's core, nuclear fusion creates an immense amount of energy as hydrogen atoms merge into helium under extreme pressure and temperature. However, this energy does not travel directly to the surface in a straightforward path. Instead, it embarks on an arduous journey through the Sun's dense layers of plasma, a state of matter so compact that photons, the particles carrying this energy, collide constantly with surrounding particles. These collisions cause the photons to change direction repeatedly, a phenomenon known as the random walk. This means that what might seem like a quick trip actually takes an astonishing amount of time. Scientists estimate it can take anywhere from 10,000 to 100,000 Earth years for this energy to finally escape the core and reach the Sun's surface. Once it emerges, it radiates outward as sunlight, taking only about 8 minutes to travel the 93 million miles to Earth, where it supports life and drives our planet's climate. This profoundly slow process not only highlights the immense density of the Sun, but also provides critical clues about its structure and life cycle. By studying this energy transfer, astronomers gain deeper insight into how the Sun generates and sustains its energy over billions of years. This process also offers a window into the behaviors of other stars across the universe, helping us understand the intricate mechanisms that govern stellar evolution. As we marvel at the complexities hidden within our star, this brings us to the next intriguing secret, an exploration into the future of Saturn's iconic ring system and its surprising fate. Now turning to the fascinating future of Saturn's iconic rings, we uncover a story of cosmic impermanence that reshapes our understanding of planetary systems. Saturn's rings, with their breathtaking beauty and stark contrasts, are not eternal fixtures but rather dynamic structures undergoing a slow and inevitable decline. This process, often referred to as ring rain, involves particles from the rings gradually drifting into Saturn's atmosphere. These particles, primarily composed of ice and dust, are influenced by the planet's gravitational pull, magnetic field, and radiation belts. Microscopic charged particles within the rings interact with Saturn's magnetic field, generating a kind of electric current that causes them to lose their momentum and spiral inward toward the planet. As they enter Saturn's atmosphere, they disintegrate and burn up, creating a phenomenon akin to a celestial drizzle. Scientists estimate that Saturn could lose its rings entirely in as little as 100 million years, a blink of an eye in astronomical terms. This knowledge significantly alters our perception of ringed planets, indicating that their stunning features may represent only a fleeting phase in their lifetimes. Interestingly, these findings suggest that Saturn's rings themselves are relatively young, potentially forming just 100 to 200 million years ago. Their transitory nature provides invaluable insight into how planetary systems evolve and the forces at work within them. By studying Saturn's rings and their gradual disappearance, scientists gain a unique perspective on the mechanics of gravitational and magnetic interactions, as well as the delicate balance that sustains such formations. This research not only deepens our understanding of Saturn's complex environment, but also invites us to consider what similar processes might be occurring in exoplanetary systems across the galaxy. As we ponder this cosmic transformation, our journey takes us next to one of the most tantalizing mysteries in our solar system, an ocean hidden beneath an icy crust where the search for extraterrestrial life takes center stage. Now turning to the icy enigma of Europa, one of Jupiter's captivating moons, we dive into the mysteries of its subsurface ocean, a place that could potentially harbor life. Beneath its thick ice crust lies a vast ocean of liquid water, kept warm by the tidal forces generated by Jupiter's immense gravitational pull. This makes Europa one of the most promising locations in our solar system to search for extraterrestrial life. Leading the charge to unlock Europa's secrets is NASA Europa Clipper mission, set to launch in the near future. This ambitious spacecraft is designed to perform dozens of close flybys of Europa, using a suite of cutting-edge instruments to study its icy shell and the ocean beneath. The spacecraft will carry tools like radar to penetrate the ice, thermal cameras to identify regions of warmer activity, and spectrometers to analyze the Moon's surface composition. These instruments will search for signs of chemical compounds that are essential for life, such as organic molecules, while examining the thickness and dynamics of Europa's ice. Additionally, Europa Clipper will study the plumes of water vapor that occasionally erupt from the Moon's surface, believed to be directly connected to the hidden ocean below. By flying through these plumes, the spacecraft can sample their composition, potentially providing direct evidence of habitability. This groundbreaking mission will not only offer a closer look at Europa's intriguing environment, but also pave the way for future missions that could drill through its icy crust to access the ocean itself. As we anticipate the launch of Europa Clipper, the possibilities it holds stretch far beyond scientific curiosity, touching on humanity's enduring question: are we alone in the universe? From exploring an alien ocean, we now look outward to the vast boundary of our solar system, where distant, icy frontiers await scientific discovery. Moving forward to the distant fringes of our solar system, we encounter two vast and mysterious regions, the Kuiper Belt and the Oort Cloud. These areas, teeming with icy bodies and remnants from the solar system's formation, hold keys to unlocking the history of our cosmic neighborhood. The Kuiper Belt, a donut-shaped region beyond Neptune, is home to thousands of icy objects, including dwarf planets like Pluto and Eris. Scientists study this region using powerful telescopes such as the Hubble Space Telescope and ground-based observatories, which allow them to observe these distant objects and analyze their compositions. Additionally, missions like NASA's New Horizons, which gave us unprecedented views of Pluto, have ventured into the Kuiper Belt to provide close-up imagery and data on these ancient celestial bodies. By examining the chemical makeup and physical characteristics of Kuiper Belt objects, researchers can piece together clues about the materials that formed the early solar system. Beyond the Kuiper Belt lies the Oort Cloud, a hypothetical spherical shell of icy objects that extends far into interstellar space. Unlike the Kuiper Belt, the Oort Cloud has never been directly observed due to its immense distance, but its existence is inferred from the behavior of long-period comets that occasionally swoop into the inner solar system. Scientists theorize that these comets originate in the Oort Cloud, dislodged by gravitational nudges from passing stars or galactic forces. To study this elusive region, researchers rely on models and simulations, using data from observed comets to predict the Oort Cloud's size, distribution, and composition. These icy frontiers are crucial for understanding the solar system's formation and evolution, as they represent some of the most pristine materials from that era. However, the challenges of studying these regions are significant, as their immense distances make direct exploration nearly impossible with current technology. Despite this, advances in telescope capabilities and potential future missions spark hope for deeper insights into these cosmic frontiers. From these icy outskirts, we now return closer to home, where another enduring mystery awaits: the search for a hidden giant planet lurking beyond Neptune. With the next phase of the journey in sight, let us delve into one of the most captivating modern mysteries of our solar system: the search for the so-called Planet 9. This elusive giant, theorized to exist far beyond Neptune, has yet to be directly observed, but its presence is strongly suggested by peculiar gravitational anomalies detected in the orbits of distant celestial objects within the Kuiper Belt. These anomalies, such as the clustering of certain icy bodies and their unusual orbital paths, hint at the gravitational pull of a massive, unseen planet lurking in the outer solar system. Scientists estimate that Planet 9 could be about 5 to 10 times the mass of Earth and may follow a highly elongated orbit, taking thousands of years to complete a single revolution around the Sun. To locate this hidden world, researchers employ a combination of cutting-edge techniques. Ground-based observatories fitted with advanced imaging technology and powerful telescopes like the Subaru telescope in Hawaii scan the skies for faint traces of light that might betray the planet's position. Additionally, astronomers analyze the motions of known Kuiper Belt objects, using sophisticated simulations and models to predict where Planet 9 could be hiding. These models calculate how such a massive planet would influence the orbits of smaller bodies, helping to narrow the vast search area. While direct imaging of such a distant and dim object remains a monumental challenge, the search for Planet 9 has far-reaching implications. If discovered, this icy giant would not only expand the boundaries of the known solar system, but also reshape our understanding of its architecture and evolution. It would provide vital clues about the formation of planetary systems and possibly even reveal new insights into the interplay of gravitational forces on a cosmic scale. With dedicated efforts and ever-advancing technology, the discovery of Planet 9 could be just over the horizon. As we ponder the mysteries of this potential new world, we turn now to another extraordinary environment within the solar system, one marked by extreme conditions and tantalizing possibilities, the scorching, cloud-covered surface of Venus. As the next challenge unfolds, let us explore Venus, a planet often referred to as Earth's twin due to its similar size and composition, yet it could not be more different in terms of environment. Venus presents some of the most extreme conditions in the solar system, making it an incredibly hostile destination for exploration. Its surface temperatures soar to nearly 900 degrees Fahrenheit, hot enough to melt lead, due to a runaway greenhouse effect caused by its thick atmosphere of carbon dioxide and clouds of sulfuric acid. To make matters worse, the atmospheric pressure on Venus is about 90 times that of Earth's, equivalent to being almost 1 mile underwater on our planet. These conditions have posed immense challenges to scientists and engineers attempting to study the planet. Early missions, such as the Soviet Union's Venera program, achieved the daunting task of landing probes on Venus, but even these robust spacecraft survived for no more than a few hours before succumbing to the extreme heat and crushing pressure. However, with advancements in technology, a new era of Venus exploration is on the horizon. Future missions are being designed with innovative materials and engineering solutions to withstand the planet's unforgiving environment. Heat-resistant alloys, improved thermal insulation, and electronics capable of operating at high temperatures are enabling spacecraft to endure longer on Venus's surface. One such mission is NASA's upcoming Da Vinci mission, which stands for Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging. This mission aims to send an atmospheric probe that will plunge through Venus's dense clouds, collecting invaluable data on its composition, structure, and possibly even its history of water. Another exciting project is the European Space Agency's Envision mission, designed to closely study Venus's geological activity and its connection to the atmosphere, giving scientists a clearer picture of how this planet transformed into such a hellish world. These missions and others like them are not only advancing our understanding of Venus, but are also driving innovations in spacecraft design that could pave the way for exploring extreme environments elsewhere in the universe. With the tools and knowledge we are developing, we may one day unlock the secrets of Venus's past, discovering whether this blazing inferno once harbored conditions suitable for life. As we prepare for these exciting endeavors, let us now journey outward once more into the distant reaches of our solar system, where icy mysteries await in the Kuiper Belt and beyond. As we wrap up our journey through the wonders of the solar system, let us reflect on the astonishing secrets that it holds. From the incredible power of the Sun as a fusion reactor to the possibility of a hidden ocean beneath Europa's icy surface, each revelation not only expands our knowledge but also ignites our imagination. The mysteries of Venus's extreme environment, the shrinking of Mercury, and the drifting of the Moon remind us of how dynamic and ever-changing our cosmic neighborhood truly is. Meanwhile, the search for Planet 9 and the exploration of the Kuiper Belt and Oort cloud highlight how much there still is to uncover, especially in the distant edges of our solar system. These discoveries are not just fascinating tidbits, they are vital pieces of a larger puzzle, one that shapes our understanding of planetary formation, the potential for life beyond Earth, and the very origins of our own existence. But the adventure does not end here. Each new mission, each advanced telescope, and each scientific breakthrough brings us closer to answering questions we have only begun to ask. The universe is vast, mysterious, and endlessly inspiring, and it reminds us of the endless possibilities that lie ahead for exploration and discovery. So, if you enjoyed diving into these incredible solar system secrets, make sure to share this video with your fellow space enthusiasts. Do not forget to subscribe to our channel, give us a thumbs up, and hit the notification bell so you never miss an opportunity to uncover more wonders of the cosmos. Until next time, stay curious, keep exploring, and remember, the universe is always waiting to surprise us.